Hello and welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the program manager for the Recycling Market Center and will serve as your moderator today. Today's topic is titled Turning Recycled Glass into a Unique Ultra-Lightweight Construction Material. And our presenter today is Teresa Liu, who I will introduce in a moment. After her presentation, we will have a Q&A session. So if you have a question or comment, you can use the Q&A feature located on your control panel on your screen. And please note that an edited version of the webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. And also please note that the Pennsylvania Recycling Market Center, its affiliates and funders, and the National Recycling Coalition assume no liability resulting from the use of any information provided during the webinar. The webinar is only provided as an informational tool and no discrimination is intended and no endorsement by these organizations is implied. Teresa Liu is the Chief Technical Officer for Aero Aggregates of North America, where her primary responsibilities include overseeing Aero's research and development activities, technical documentation, engineering support, quality control, program, and education and outreach efforts. Teresa brings to Aero's management team over 15 years of combined industry and academic experience. In the past, she has been involved in and managed a variety of civil, geotechnical, and geo-environmental consulting and construction projects in the Mid-Atlantic United States. Additionally, Teresa has taught geotechnical and other civil engineering courses at Rowan, Drexel, Temple, and Bucknell universities, and is the current vice chair of the Geo Institute's Delaware Valley chapter. And I'm going to turn the program over to Teresa.
All right, thank you so much, Wayne. And thank you all for joining us today. As Wayne said, my name is Teresa Liu. I am our technical lead at Aero. So I'll just give you a little bit of my background, just so that you forgive me when I maybe am not able to answer some of the hard questions that I expect you guys to ask me at the end. My background is geotechnical engineering. So I do have several degrees in that. And so a lot of my focus within Aero has been kind of on the application end of our products, right? Civil engineering, where the material would actually be used. But, as we started as a small company, I've been involved in many different aspects to date. And so, I'm going to share a little bit about kind of the history of our company, how we do things at Aero. And yeah, I really look forward to it. All right, and before I do go forward, I just want to thank Wayne and the PA Recycling Market Center for inviting us to speak. They've been a great resource for us as a company involved in using recycled glass here in the state of Pennsylvania, and just truly a very great resource for us. All right, so the product that Aero makes is called Ultra-lightweight Foamed Glass Aggregate. And the photo that you see on the screen is a picture of foamed glass. I put the ruler down there at the bottom just so that you get an idea of scale. So it's a 12-inch ruler. So you can see that the particles themselves are going to be on the coarser side of most aggregates that civil engineers are used to seeing, right? So more of a ballast rock size as opposed to a typical 3/4 inch or 57 stone aggregate. This photo also gives you, I think, a pretty good idea of what that surface texture is of our material, right? So oftentimes I describe foam glass as a manufactured pumice material. All right, so we are made from, post-consumer recycled glass. We're not using, silica, anything like that to make glass. We're using all recycled glass in our process. All right, so if you've never heard of foamed glass aggregate before, these are some of the attributes that we like to talk about in reference to our product. The first thing is that UL in front of the FGA abbreviation, and that stands for ultra lightweight. And the reason why we coined this ultra lightweight instead of just lightweight is because there have been many different types of lightweight aggregates available, in the marketplace for many decades now. And, here Aero was started, well, we started making product about 5 years ago, and nobody had really looked to use foam glass aggregate for some of the uses that we were, at least here in the US. And so, we're kind of the lightest of the lightweight aggregates, is like what we like to say. All right. So along with that, being a lightweight material, we're also a very good insulator. So materials that have a lot of entrained air in them tend to be good insulators because air is a great insulator. We also have a high friction angle. So in geotechnical engineering, the way that we describe the strengths of soils or aggregates is by their friction angle and cohesion. And so the higher the friction angle, the higher the shear strength you're able to mobilize at a given normal stress. And so 54 degrees is what we typically see from our shear testing that we do. And that's, anywhere from a typical aggregate might come in at, say, 40 or 45 degrees, and all soils are generally going to be less than that. So you can see that, we're getting much higher friction angles than what would be typical for aggregates. All right, our product's also going to be frost resistant. And what we mean by that is you can see the surface. There's, bubbles, obviously, on the surface of the aggregate. There's bubbles on the inside as well. But the closed cell foam glass, those bubbles are not going to be accessible by, water on the exterior of the particle. So, water is not going to be able to be absorbed into a closed cell piece of foam glass and then freeze and crack up the aggregate or anything like that. So we're a very durable material in that way. We act as a capillary break, and this is more an effect of just particle size. Right, the water is not able to find its way up through the voids because the voids are so large when you have a very coarse aggregate. Along with that, we're very free draining. And, in place, we've done some testing to prove out that we have about 45% porosity or greater in place. And that's just the interparticle void space is about 40% of the volume of your layer. We're a good load-bearing layer, right? You can put kind of the equivalent load of, say, a shallow foundation or shallow footing for a building, but we do have some limitations here in terms of dynamic and static loads. So you're not going to be able to use this everywhere. You're going to have to, keep an eye on that if you're looking to use foam glass in your design. And then the last thing that I have on the slide is just we can be very useful in cases where you're analyzing a design for the seismic case, all right? Just because, if you're reducing the mass of what will shake during an earthquake, you're going to be reducing then the forces that are applied to the structures that you're designing. All right, so very briefly, just a little bit about the history of foamed glass aggregate. As far as we can tell, there was some initial research that occurred here in the US in the late 70s and a little bit previous to that as well. And they were primarily looking to use recycled glass to make an insulation material. Right, as far as we could tell, nothing really happened with this information, but in the 80s, the technology was developed in Germany to be able to mass produce foam glass aggregate. And then that technology was sold in the 90s to a Norwegian company that still exists today. And they were looking to make a material that could act as a thermal barrier in their roadways, right? So in Norway and elsewhere in Scandinavia, they obviously have some pretty cold temperatures. And they also have a lot of very soft, clayey, high moisture content subgrade soils. All right, so when you combine those two things, right, you have a high moisture content clay that's going to freeze and expand during the winter. And if that occurs underneath of the road, it's going to, force the road up, heave it, and cause damage to the pavements. So in Norway, they were seeing a lot, just a lot of costs associated with maintaining these roads that were continually getting beat up due to the frost cycles. All right, as they started using it in that application as a thermal barrier, it then led to other lightweight applications where, they were just like, we need to reduce the weight on these underlying soils or on this structure or on a utility. And then the use is kind of expanded out from there. All right, so today there are many manufacturers. Many of them are located in Europe. In the Scandinavian countries of Norway, Sweden, and Finland, there are several plants located there, and they use foam glass aggregate extensively for infrastructure uses in those countries. In Germany and elsewhere in Central Europe, there's also many plants, but the focus for those plants tend to be more as the product as an insulator. So more around the building envelope, not necessarily for use in infrastructure works. All right, so as I said, our product is made from post-consumer recycled glass. It's generally collected curbside. And I know that this audience that I'm talking to now, you all are probably well versed in some of these statistics that I'm going to be sharing, but I always ask this whenever I present. I do a lot of education to engineers, architects, other stakeholders involved in our projects. And when I ask this question, so many people are very surprised to hear that we're actually only recovering a little over 30%. And that's just for container glass here in the US, right? I show this graph, this figure, and everybody's always very disappointed, right? Because certainly I grew up learning that glass is this endlessly renewable resource that you can just continuously recycle it into a new glass bottle or jar, and then you see that the data, and it's very clear that we're not even doing that for 1 out of 3 of our containers that we're using. All right, and as far as I can tell, this is definitely not my area of expertise, but as far as I can tell, there's a bunch of reasons for this, but I'll just highlight a couple of them. And the first one is that, right, most of our waste is managed in this country on a very local level, right? So you have, maybe challenges related to organization, resources, that sort of thing, right? You just, everybody can make their own decisions. And it just, it lends itself to a, somewhat broken up system in how we're collecting glass, how we're recovering glass and recycling it. Another issue is that the US is a very large country, right? We, in terms of land size, it's vast. So, connecting the population centers that are generating, a lot of this glass with the end user that actually wants to recycle it into a new product, that can be difficult because, we're just so spread out. And then I guess the third thing I'll bring up is that, here in this country, there are several states that do have bottle bills that are active, but many don't. And so we're dealing with single stream recycling programs that, just in general, create a stream of glass that tends to be higher in impurities and just in general more difficult to recycle, right? So that's another thing that's contributing, to some of these statistics. All right, so just, so that, whenever I'm presenting this to others, I do like to show this figure, which is from the container glass the European Container Glass Federation that puts out this data, again, related to container glass recycling over in Europe. And, we can really aspire to what some of these countries are doing. Certainly we can look at those countries in Scandinavia that are, over 85%, all of them. But in general, right, like almost every country is doing better on the whole than we're doing currently in the US. All right, so I want to tell you a little bit about how we make our product. One of the things I haven't mentioned yet is that we're actually able to take the glass that generally nobody else wants to take in order to recycle it into a new, a new product or a new material, right? And that's these fine bits of mixed color glass that, as you know, generally can't be used to make a new glass bottle or jar. And that's because they're too small to be properly color sorted, right? And most glass recycling processes do need all of the same color glass in order to feed the bottling lines. All right, so we're able to take these fine bits that, as I said, generally nobody else wants. When we get it, as you can tell, it's a fairly dirty stream. Certainly we work with many different suppliers, and there's different values to the glass that we receive. Certainly the dirtier the glass, the less value it has to us, because we have to put in a lot of energy and effort in order to pull off all of these impurities that are not the glass that we're interested in. All right, so the very first step in our process is to do the best that we can to clean the glass. All right, and the way that we do that is everything's dry. All right, we're not using any type of effluent or wet process anywhere. We're using a lot of screens. We have several magnets in the system, vacuums, dryers, those sorts of things. But generally, it's a completely dry process, and we're trying to get the glass as dry as possible during this process as well. All right, so at the end of cleaning, we hope that the glass looks as clean as what I'm showing in this left-hand photo. At the end of the cleaning process, we should be left with a majority of just glass. And so the next step in our process, our glass processing, is that we need to take these fine, these bits of glass cullet that are generally coming to us, about 3/8 of an inch in size. We need to take that down to a very fine powder. I liken it to kind of the all-purpose flour that you would, bake with. It looks very similar to that. The particle size is about 65 microns and finer. And when you mill the mixed color, glass cullet, when you take it down to that particle size, the glass can't reflect light in the same way. And so we truly are left with kind of this off-white, creamy colored powder that does look very similar to all-purpose flour. All right, so we do that using a specialty glass mill. You can see the mill set up and part of the classifier here in this photo on the right. It's a pretty efficient mill. And at the end of this process, we're able to store any of the glass powder that we make in silos that are located outside of our building. But everything in terms of the glass processing, so cleaning and milling, is all happening under roof. All right, so when we're ready to make our product, we're gonna bring that glass powder back into the plants. And I like to show this photo just to orient you to what a foamed glass aggregate kiln looks like. All right, so the kiln itself is this boxy structure here towards the back of the photo. Here on the right, you see kind of a 2-story structure. And up top, we have our batch plant with the 2 cylinders here. And directly underneath is a mixer. All right. Extending from the back side of the kiln is a cooling table. All right, just letting the product have some time to cool after coming out of a very hot kiln. And, kind of the time that it takes for, the powder to move from, the front side of the kiln to the back side of the kiln, it takes about 40 minutes. All right, and then it'll take another 40 minutes to move along the cooling belt before it goes to the conveyor and head outside. All right, so our process to make foam glass aggregate is we're gonna, number one, take that glass powder that we just made, and we're gonna mix it with a foaming agent. And our standard product that, by far is the majority of what we have made in the 5 years that we've been in business is a closed cell product that we use a foaming agent called silicon carbide in order to make. All right, silicon carbide, also known as SiC for short. It's also a recycled mineral from another industrial process. But in this first step, we're basically just mixing the two powders together. All right, it's about 99% glass powder and about 1% by weight of our foaming agent. All right, so we do that in the batch plant. It drops down into the mixer. And then once those two powders are mixed, it drops onto the belt of the kiln. All right, so this powder mixture, it's screeded off to be a consistent height right around 20 millimeters. And then it starts to go through the kiln. And inside of the kiln are, I think we have 13 or 14 different unique temperature zones. All right, and those temperatures, it's all related to the science of being able to foam the glass properly, right? So the first thing that we want to do is we want to soften the glass. Next thing is we're activating that foaming agent to create an air bubble. We're sintering the glass powder around that air bubble in order to trap it. And then we're heating it to expand the air bubble in volume. Okay, so, different temperature zones could range anywhere from, say, 600 degrees Celsius all the way up to about 1,000 degrees Celsius, depending on where you're at inside of the kiln. All right, so if we look at the back side of the kiln where material is exiting, this is what we see. And it's a solid foam glass cake at this point. It extends the full width of the belt, which is just under 2 meters. And we've expanded that powder height. I mentioned it started at around 20 millimeters. When it's coming out, we've expanded it to about 70 to 75 millimeters. So you're seeing in, volume expansion of about 3 to 4 times that initial powder height. And if you would walk along the cooling table, with the product, you would be hearing this snap, crackle, and pop sound. And what that is because of the temperature differential from being in almost a 1,000 degrees Celsius kiln to then being exposed to, say around 20 degrees Celsius room temperature air, that is inducing thermal stress into the foam glass cake, and the cake starts to crack up. So by the end of the cooling belt here, we've already created kind of these aggregate sized pieces that are going to fall onto the conveyor, as you see here, and head outside. All right, so product is still certainly warm here at this stage. It's not completely cooled off, but it's cool enough to have induced that thermal cracking that's necessary to have pieces of product. All right, so at this point, it goes onto the conveyor and it goes outside. We do isolate product until it's been quality control tested, but once it is QC tested, it goes into the larger product stockpile. So this is an aerial photo of our plant in Pennsylvania. It's in Eddystone, PA. And you can see kind of the scale of what we're doing. We're, certainly, have a substantial stockpile of material. It's not quite as big now as it was when this photo was taken, but we're supplying some very large projects. And so, we do need to plan for that and have a pipeline of what we expect, to happen in the next couple of years. Also, I'll just point out, the silo, as I mentioned, is where the glass powder is stored and kind of that interim step between all of the glass processing that we have to do and then the actual foam glass aggregate manufacture. Okay, so I do like to clarify that there are different types of foam glass, and the process that I just described to you is the dry process of manufacturing a closed cell foam glass aggregate. This is by far the majority of the product that we make. There is a way via a wet process, so using a different foaming agent, to also make closed cell foam glass aggregate. The companies that are manufacturing wet process material generally are making a less dense product where they're more interested in the insulation value than they are, say, the durability and the strength characteristics. So, wet process is not maybe a material that you would want to be using for infrastructure uses, but certainly in the building envelope applications, it's going to be a very good product to use there. And then there's a different type of foam glass that we call open cell material. And, as I said previously with the closed cell, which is not absorptive, if we switch out our foaming agent, we can make a product where those voids on the interior of the product or interior of the particle are more interconnected. All right. And, that's what we refer to as our open cell product. And this is going to be an absorptive material. Okay. So you're going to have much higher moisture contents in open cell foam glass. Also, more accessible surface area because of those interconnected voids. And so the applications for open cell foam glass tend to be things related to agricultural uses. So growing medias, whether it be in green roofs as an amendment, it could be used in aquaponics or hydroponics systems. There's also applications for open cell material for air and water filtration. And again, here it's kind of that increase in surface area where is really being, the benefit is here. And then there's some unique applications for open cell as well, things like energy and sound absorption. All right, so if you do see the trade name Growstone, this is our trademarked name for the open cell product that we will make, or at least the majority of the open cell product for those types of uses. All right, but as our company is expanding, we did find it useful to define some, say, pillars that define some of our product categories. And so you can see them here. Our original name for our company, Aero Aggregates. This is the ultra lightweight or insulation material for infrastructure uses. So, certainly it's the majority of material that we've supplied to date, but that might be changing in the years to come. The middle pillar here, the Growstone pillar, this is our open cell product where you're looking to use the foam glass as a moisture retention material or as a soil aerator. And then the third pillar, the Aero Light pillar, this is kind of our catch-all. It does have both open and closed cell foam glass aggregate for all sorts of applications. So the filtration applications kind of live under the Aero Light pillar, as do some areas of R&D for us. And I'll just mention these. These also include sized material for use in lightweight concrete mixes, as well as sized material for use in lightweight cement or composite block materials. All right, and we have had, just give a shout out to Penn State and the larger state of Pennsylvania. They have a wonderful program. It's called the Pennsylvania Manufacturing Innovation Program, where private companies are able to partner with universities in the state in order to, explore opportunities for growth. And so we were actually awarded, this is the second time that we were awarded a project with Penn State Harrisburg in order to pursue, a project under this program. All right, so I did mention that our company is experiencing a lot of growth right now. And so you can kind of see our proposed footprint here. So our very first plant, and where I'm based out of, is our Eddystone, Pennsylvania plant. Eddystone, if I didn't mention it before, is just right outside of Philadelphia, very, very close to the Delaware state line. We just opened about 2 weeks ago. We started making product at our facility in Dunellen, Florida, which is about an hour and a half north of Tampa. So we're very excited about that. We did have some delays in this process, some of which were pandemic related, but we're very happy that we're going to be actually having our grand opening for the Dunellen plant next week. And then we announced earlier this year that we've partnered with a recycling company to be opening a facility out in Modesto, California. And this will be happening probably towards the end of this year, but that will get us out to the West Coast. And then we have not officially announced it yet, but I did get approval to tell this group that we will be opening a facility in Massachusetts in the September-October timeframe of this year as well. So there was a great opportunity for us to do that, and so we're taking it. All right, so part of my responsibilities here at Aero is to oversee kind of our quality control program and other types of material testing and product approvals that we need in order to be used, on projects, that are related to DOT work and other types of infrastructure work. So you can see some of them listed here. We do have a QC program where all of the material that we make each day is being tested. We're collecting samples throughout the day from all of the kilns that we have, to make sure that it's meeting our primarily strength and density requirements. We've also done additional testing to kind of prove out the application areas where we see foam glass aggregate as being beneficial. So this includes testing to the AASHTO standard for MSE wall backfill, doing all of the durability and electrochemical testing requirements that they have. We did large pull-out testing where we're able to look at different types of reinforcing materials that you could use in combination with foam glass in MSE systems. We've looked at permeability tests. We've also done several different types of thermal conductivity testing in order to back out an R value for the material. All right, so shifting gears a little bit, I just want to tell you a bit about kind of the application areas for foam glass and how we see it being used. And I am focusing on kind of the the infrastructure uses here, but I'll also mention some commercial uses as well. All right, so as a geotechnical engineer myself, right, if I'm looking to use a lightweight fill material, generally for me, it's going to be that I need to reduce the load or weight either on soft compressible soils that obviously are going to be susceptible to settlement, which will create a serviceability issue down the line. I might want to reduce the load or weight on some type of structure, and this could be a retaining wall, a bridge abutment, could be a parking garage, anything like that. Or it could be to reduce the load or weight on a utility, and most of the time this would be an existing utility, not a new utility. And then, the second reason why you might want to use a lightweight fill material is to provide that insulation value. And this really is, mostly would come into play in colder climates, unless you're looking to use it maybe around the building envelope. All right, and in the upper right, I just have, just a brief unit weight comparison for different types of fill. So, the highest here on the left, we have soil coming in at around, on average, 120 pounds per cubic foot. Your aggregates, right, your stone aggregates are going to be a little bit less than that at around 100 pounds per cubic foot. The traditional lightweight aggregates that have had a majority of the market share in this country have been expanded shales, clays, and slates, and they on average have an in-place unit weight of about 60 pounds per cubic foot. Foam glass aggregate we're showing next, and that's right around 20 PCF in place. And then there is an alternative material called geofoam, which is made from expanded polystyrene, and you can actually see some of the photos here. They're just these large blocks of basically styrofoam that can be used, in certain areas where you really want to almost completely eliminate any load or weight. So the in-place unit weight for that is somewhere between, say, 2 to 3 pounds per cubic foot. All right, and here's just another slide showing you a comparison of some of these materials. This in the upper left right here, this is an expanded shale type of product. In the upper right, I didn't mention this previously, but there is a material called foamed concrete or cellular concrete that is used as well as a lightweight material. So in this case, your foamed concrete is made by mixing a foaming agent with cement and water, and then spraying it out like you see happening in this picture. And they can really dial in their unit weight. So they could be as light as, say, 20 pounds per cubic foot, or as heavy as, say, 60 pounds per cubic foot. The middle photographs here are showing you waste tires and wood chips that have been looked at in the past to maybe be used as a lightweight fill, but they're certainly not popular for the reasons that you can probably imagine. And then here at the bottom, again, we just have a picture of geofoam and then foamed glass. All right, so here are the schematics that we put together to help you visualize how foam glass aggregate could be used in these infrastructure applications. So in the upper left, we're showing building up an embankment, or in this case, it's showing you a roadway embankment, but it could be a railway embankment with foam glass. Maybe you have soft soils under here that would be susceptible to settlement. In the middle picture, we're showing you fill behind a retaining wall, right? So this is more a traditional retaining wall without reinforcement, but you could also have reinforcing elements in the fill, right? That would be what we call a mechanically stabilized earth system. If you're doing any type of roadway widenings, say you have to add another lane or expand the shoulder, in a roadway embankment, frequently if you have, clay soils, underneath of the road, what you're going to be doing if you build up the embankment adjacent to your existing embankment is you're going to induce settlement in that area, right? So, if your existing embankment has been in place for 50 years, that those underlying soils have obviously had time to consolidate under that weight, but your expanded shoulder area, they certainly have not. So if you utilize lightweight fills, now you can start to mitigate some of those settlements. All right, on the bottom, we have fill over tunnels or culverts. Again, just reducing the load or weight on these structures and maybe even start to optimize them structurally. Fill over or around utilities. All right, so this has been a pretty large application area for us, more on the existing utility side of things. But we also see potential for foam glass to be used as an insulating fill material over or around the utility. So let's say you have, a water pipe that you can't put below frost depth for some reason, now you can, use foam glass as either backfill around the pipe or just over top, and hopefully shield it from the cold temperatures in the winter and prevent that water pipe from freezing. And then the last schematic here is just showing you an example of a load distribution platform. So this would be where we want to build up a roadway embankment, but we have very soft soils. And so what we're doing is we're using a deep foundation element to transmit the load of the embankment structure down to a stiffer layer below. And so, if you, instead of using normal weight materials for that embankment fill, if you use a lightweight material, now you can optimize the number of the deep foundation elements that you have to use in these systems. All right, and we did put together this schematic showing you how we can, help address some of the issues related to resiliency concerns on projects. And most of the time when folks are looking at using foam glass, it's because they're faced with having to raise the grade of their site due to an increase in the flood elevation. All right, we see a lot of projects where, kind of the total elevation change that needs to happen is on the order of about 3 feet, right around there, 3 to 4 feet, in order to, raise the site out of the 100-year floodplain is mostly what is looked at. And I can tell you as a geotechnical engineer, these areas close to waterways, these are where we have some of the most marginal soils. Okay, so these are the soils that are going to want to compress when you put an additional load on them. And so, if you're using now a lightweight material to do your grade raise, you're going to be reducing the stress on the underlying soil. So, hopefully you won't see settlement in this embankment, over time. Another benefit that we really saw in these situations is that the in-place layer of foamed glass has a 40% porosity, right? So that's just the interparticle void space. And a lot of these sites, every site, right, has to be able to manage stormwater. And so now you have an embankment fill that has 40% void space that could be filled with water, during one of these storm events. And so you can kind of get a double use out of the material in certain cases. All right, here are some schematics that just show you the use in commercial and really even residential construction. So here on the left, we have fill either under slab, right, or around foundation or basement walls. And again, this could be, you have to raise your ground floor slab to, be out of the floodplain. Any type of grade raise over soft soil, you're going to have to do some type of mitigation, whether it be traditional ground improvement or using lightweight fills. Or you could just be looking to use it as an insulation material, right? To get rid of your pink or blue board XPS insulation that you typically see sub-slab and on, basement walls. And then, the green roof applications and plaza deck applications here, it's just, you might be looking for a layer to be doing some grading over top of a structure. You might need a drainage material underneath of your pavers. So anywhere where you're over top of a structure, generally you want to be minimizing the weights from what's going on top. All right, we do have some benefits in shipping because we are a very light material. So if we're shipping to our project sites in bulk, we like to use these walking floor trailers that you see in the upper left. We like them for a couple reasons, but the main one is that we can get close to 100 cubic yards in a single load going to site. And then a second reason that we like them is that, you can get the material out of them by just activating the walking floor, and you don't have to tip up the trailer. You can't tip up the trailer. It's not designed for that. And so because of a lot of our projects are, sites with soft subgrades, we really see this as a safety benefit as well. We can also bag material, and you see that in the bottom photos. Our current bag size, I think, is a 3.4 cubic yard bag. So very large super sacks that we can then either put on flatbed trailers to go to a project site, or we can put them in an intermodal container so that it'll travel at least part of the way via train. All right, and this, you guys are getting a little preview. We're putting out this graphic for Earth Day tomorrow. But this is just showing us, showing everyone how we are kind of contributing to the circular economy, right? So we're using, post-consumer waste glass in order to make our product. Our production facility here in Eddystone is a brownfield site. We're then making the product and shipping it all over the country, being able to do that pretty efficiently because of, how light it is. And then that material is being utilized in, many of the same communities where we initially collected that glass in the first place, or, not we collected it, but where it's being sourced from. All right, so now I just want to show you just a couple photos from some of our projects. This is one of our largest resiliency projects to date, and it was for Avalon Bay communities that this developer wanted to put new condominiums and townhomes on this site. This is on the southern coast of Long Island, former industrial site. So the whole site had been capped. They really didn't want to disturb those kind of existing in place soils. But because of post-Sandy flood elevations, the entirety of this, I think it was an 11-acre site, had to come up between 5 and 6 feet. All right, so this site also had soft soil concerns. So they did about 4 of the 6 feet, raising the grade with foam glass. And here you can see the exposed area in the back, this lighter gray color. That is all foamed glass aggregate that has not been covered yet. But an additional benefit on this project is that they were actually able to utilize the layer as part of their stormwater management system. All right, so you can see, a lot of the manholes and stormwater piping that was incorporated into the layer itself. All right, this is a large DOT project in New Jersey. It's in Kearney. So it's the Route 7 ramps related to the new Whitpen Bridge construction. This area in Kearney, it's right adjacent to the Hackensack River. There's about 60 feet of very, very, very soft clays in place. All right, and when you're dealing with that thick of a layer of soft material, there's really no way to do ground improvement other than either using lightweight materials or putting a surcharge on and waiting, months to years for that consolidation to happen before you start to build. All right, so they chose to do actually a combination of those things, but they're utilizing foam glass on the construction of many of these new ramps associated with the bridge. I really like the photo on the right because you can see how they're building up the embankment with the foam glass aggregate. This black fabric is just a non-woven geotextile, basically a filter fabric. And then on top, they're putting a layer of what they call DGA, dense graded aggregate, which is part of the pavement section on top. All right, this slide is showing you, how, part of what we have to do at Aero is to get folks to think a little bit differently about their designs. Okay, and this is showing you how, let's say you're designing a retaining wall. When you're looking at the lateral pressures that are generated from the retained soils, that's going to be a combination of the unit weight of those materials as well as the friction angle of those materials. All right, so the lower the unit weight, the higher the friction angle, the more you're able to reduce these lateral pressures. All right, so, as we said, foam glass, it's the lightest of the lightweight aggregates that's out there at around 20 PCF. in place. And then with a very high friction angle, you're able to take these lateral earth pressures to, 80 to 90% than they would be with traditional, soil backfill. And so, it's kind of this, give and take, right? There is going to be a higher cost for using foam glass instead of traditional backfill, but now you can start to optimize the structure that you have and see significant cost savings in the cost of the structure itself. All right, and so this was a project that was kind of driven by those concerns that I just mentioned. This is along I-80. It's in Denville, New Jersey. So this is where 80 crosses the Rockaway River. And the DOT was replacing this dual span bridge. However, they wanted to reuse the existing abutments. Okay, so they wanted to reuse the abutments, but the new spans needed to be about 5 feet taller than they originally were because of hydraulic reasons with the river itself. All right, so they needed to design then a vertical extension, put that on the abutment, but they were worried that if they put normal weight backfill behind that extension, they would start to have issues with, say, structural integrity. So they chose to use foam glass aggregate for the backfill behind that new vertical extension on the abutment. And you can see it on the left-hand photo, this kind of diamond-shaped area is where they were placing it behind the first abutment that they did, but they did utilize it for all 4 of the abutments. All right, this is a project that occurred in Philadelphia. There's a lot of work related to I-95. There's only about 50 miles of 95 in Pennsylvania, but I feel like they're working on at least half of those at any one time. But this is work just right north of Center City, and it was related to an on-ramp for 95 South. So in the upper right, you can see the existing on-ramp. All right, it's an elevated structure. So, it sits on these piers, which are then founded on deep foundations on piles, all right, but below the piers. And so they were switching the design from being this elevated structure to being an embankment. And what the concern was is they needed to keep this on-ramp in service, but if they built up this embankment right beside the piers with normal weight fill, they were worried that they were going to start to kind of squeeze the soils beside those existing deep foundations and undermine this structure. Okay, so it was basically a constructability issue that caused the need for lightweight fill in this section of the embankment. And you can see this fabric in the bottom left. This is a type of geogrid reinforcement that was used behind the new abutment for the ramp. All right, this project was at Logan Airport in Boston. Again, associated with a new ramp connected to a new parking terminal, I believe. The total height of this embankment was just under 20 feet. Logan, like many airports, is built almost entirely on reclaimed land. So, you're faced with whenever you're doing a grade raise, you have to mitigate for settlement because you would almost assuredly see settlement over time in these areas. So at Logan, this was another embankment structure that was reinforced. In this case, the strips that you see here are made out of galvanized steel, but they do the same job of reinforcing the mass of aggregate. All right, this project was also in Philly. This is at Philadelphia International Airport. And the project is related, you can see the highlighted area. Basically, they wanted to create a parking lot for jets to stay overnight at the airport. And this was an effort to expand some of the cargo carrying capacity at Philly International. Philly International, just like Logan, lot of reclaimed land in this area. So whenever you're raising the grade or putting in pavement that's a lot more dense than the existing soils, you do have to mitigate for that. And so you can see it wasn't a consistent thickness of foam glass aggregate. It did vary, say anywhere from 2 feet thick to maybe 10 or 12 feet thick, depending on kind of existing conditions and proposed conditions. So here you can see in progress some of the work that was happening. It was a nice large area. We do think that this is probably the largest foam glass aggregate project in the world to date. Here is, we just are highlighting the excavation. You can see kind of this layered soil that is existing, and that absolutely would create problems over time in terms of settlements. And then here it is a little bit closer to complete. And I do like to mention that we were actually able to supply over 3,000 cubic yards a day to this project. So, the total amount that we supplied was close to, I think, 100,000 cubic yards, but we were able to do that, in a matter of, say, about 45 days. All right, I just want to, I think this is my second to last project that I just wanted to show you, but this is, we're utilized frequently in situations where you do want to use foam glass as an insulation material. And it seems to be very popular, with some of the green building organizations and passive building designs. And so here, what we're showing is that the foam glass actually is replacing two things that's typical, sub-slab that you would see. And the first thing is, your rigid EPS or XPS insulation board. And then the second thing would be your gravel capillary break layer. So foam glass can replace both of those things. So it's not just kind of a one-for-one with the insulation, which is frequently what people look at, and we kind of have to explain that no, you're actually, you have to look at this as a system. All right, so here is just showing you some drawings from a passive home construction on Cape Cod, but you can see that they're using a decent thickness of foam glass sub-slab as well as around the basement walls. And here is that material going in. We were able to supply this project in bags so that the bags could just be opened up and easily installed in place. All right, and then here is a project in Camden, New Jersey, related to a new pier redevelopment. So the existing pier is over 100 years old, and there's a lot of development happening in Camden right now, including, headquarters for a company called American Water. There's an aquarium just south of this site, and it's just seeing kind of a resurgence, at this point in time. And so they wanted to create a nice lookout spot on the pier so that you could see Center City, Philadelphia across the Delaware River. But they were worried about the structural integrity of, this 100-year-old pier. They really weren't sure kind of what the condition of everything was. And so, even though this, hill is really only about 12 feet tall, they didn't want to build that out of normal weight fill because of those reasons. So you can see this is a photo during construction. The lighter gray is obviously the foam glass. So they were building up the mound. The black fabric, again, is just a non-woven geotextile. And then they were placing cover soils, which is this lighter tan material here on top. And so not a great photo, but you can see the completed pier in the background. The mound is right here. The aquarium's there in the background. This is the Battleship, New Jersey. But again, just a solution for this issue that they were having for historic structure. And I'll just also mention foam glass was used under the ground floor slab of this new hotel as well. This is a Hilton Garden Inn that was constructed just after the pier was complete. All right, so with that, I thank everybody for your attention and attendance today, and I'd be happy to answer any questions that you have to the best of my ability. Yeah.
Okay, thank you, Teresa. That was a great presentation. A lot of information, a lot of interesting projects that use this material on. So, and I'm sure there's going to be a lot more. So we're now going to field some questions for Teresa. If you have a question, use the Q&A feature on your control panel. And it looks like we have a couple here already. This attendee works at a university, and they're curious if they can get a sample for educational purposes.
Yeah, absolutely. My email address is on the screen, so please just shoot me an email of what you'd like and a good address, and I'd be happy to hook you up.
Yeah, you mentioned you've worked with Penn State Harrisburg. Have you worked with any other institutions, any other higher education institutions?
Yeah, we have. So we, a lot of the testing that we have done, we have partnered, not necessarily with the institution itself, but with various professors at different higher education institutions. So we do have a grant that was awarded this year with Villanova University, but we have worked with others in the past. We've worked with a professor out of Lafayette, which is also here in Pennsylvania. And some others, but again, it's more of working with the professors as opposed to the institution itself.
Is this material also recyclable?
So foamed glass, it can be reused. You would see some breakdown of particle size as you handle it more, but certainly you could move it from one area where it's been installed to another. But in terms of it being recyclable in our process, we could probably handle recycling a little bit of it, but the reality is that the foaming probably wouldn't lend itself to being recycled in our process very easily. Like, number one, we're not set up for it, but number two, the oxygen that we pull from the glass, it hasn't been completely exhausted, but there's going to be less of it if you keep recycling the product. So it's not ideal for our process.
Yeah, but for the most part, the applications of this material is a permanent insulation.
Yeah,
so
exactly right.
In theory, you won't be recycling it. Something like maybe a green roof, you could reuse the material in another green roof project. But I think reuse would be the best option for this material.
Yes, I completely agree. Yep.
Okay. Do you envision having a plant in the Midwest in the future?
Yeah, I mean, I would say nothing's off the table for us at this point. We, where a lot of things go into the process of us deciding where we are going to be opening our next facilities. But nowhere is off the table.
Mm-hmm. These two questions are related. How does your firm source the post-consumer glass? And then do you take glass from single stream MRFs directly, or does it have to be processed, interim process from the MRF?
Yeah, no, that's a great question. So we do a little bit of everything. We do take glass cullet directly from some MRFs. We also work with glass processors to take, a lot of the products that they can't necessarily use or sell to anyone else. But if you're involved with a, locality or company that might have glass that, you think we might be able to help, use in our process, we certainly would love to have the conversation with you. So, if that is the case, I know that, some folks on the call that may be the situation for you. And as we're expanding across the country, we definitely have to speak with more people than we've had to speak with, just being located in PA for the last 5 years. So we'd love to talk to you, and please, again, my email is on the screen. Please get in touch with me, and I can get you to the right person here at Aero to talk to.
Okay. What is the durability of the material? Does it break down over time? Is that accounted for in these projects?
Yeah, so the more that you would handle foamed glass, the more you would see some particle breakdown or particle sizing. But the idea is that you're really only handling it in order to load it onto a truck, get it to a project site, and for it to be placed. So again, if you think back to those schematics that I showed, right, pretty much every application that we're talking about, the foam glass layer is going to be covered by, another layer of soil or by a concrete slab. So once it's in place, there's really no opportunity for the material to break down further, as long as the system's been properly designed.
Yeah, I can attest to firsthand handling this stuff. I have samples and we show them at some of our events, and just handling it, it's just like handling pumice stone. The friction causes a little bit of dust to be created. So, but like you said, once it's placed, it won't move.
Right. So, exactly. No opportunity for that breakdown.
Yep. Okay. All right. I think that's it for the questions. So we're going to wrap it up. So again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thanks again for joining us, and we hope you'll join us for next month's webinar. Please visit the NRC and RMC websites for schedule updates. And again, thank you, Teresa, for this great presentation and taking the time out to share this information.
Yeah, it was my pleasure. Thank you all for joining.
All right. Have a great day, everybody.